Hello everyone, welcome to this lesson. So in this lesson, we're going to be starting a new series called Roots of Equations. Now in this lesson, I'm going to be describing what are roots of equations. We're going to go through recapping how you analytically found roots of equations up to this point, and also introduce the four methods we're going to be introducing to find roots of equations. And of course, we're going to be developing the Python codes for these four methods. So what are roots of equations? So roots of equations are actually simply the x-intercept. They are where the function crosses the x-axis or where the function is equal to 0. In this case, we have a function x squared minus x minus 2, and this is a second order polynomial and has two roots at -1 and 2. Now, normally you would use a technique called factoring to find roots of equations, and you would basically take the function, place it equal to 0. This is a second order polynomial, so it has two factors here. You would find a number that would multiply, or two numbers that would multiply equal to -2 and would add up to -1x. And these two numbers are -2 and +1. And you would take each one of these factors, place it equal to 0, and that would give you x equal 2 and x equal -1. And these will be the roots of this equation, or the x-intercept. Now we're going to be going through two main types of root finding techniques: bracketing methods, which bracket the root. They use two guesses to bracket the root, and because of this type of bracketing, they always converge to the answer eventually. We're going to be going through the bisection method and also a more precise or more accurate form of the bracketing method, which is called the false position. Then we're going to go through open methods, and the reason they're called open methods because they use one guess, and because they use one guess, they have the potentiality of diverging. We're going to be going through the Newton-Raphson, which uses the exact derivative of whatever function you're trying to get the root for, and the secant method is actually a version of the Newton-Raphson, but instead of using the exact derivative, it uses an approximation of the derivative, either using the centered, backward, or forward finite difference. Now, to recap, what are roots of equations? They are simply the x-intercept, or where the function is equal to 0. And we are going to be covering from the first lesson the bisection method and its corresponding Python code, move to the false position and also its corresponding Python code, and the Newton-Raphson, then the secant. And most importantly, we're going to go through how each one of these compare to one another. And when it comes to numerical methods, we see the accuracy in how fast do they converge, how many iterations do we need to do to get to the desired error value. And we're going to see which one and in what circumstances is these techniques actually superior. Well, that's it for this lesson, and I will see you in the coming lessons. Thank you.